All right, let's go ahead and get started. This is the internet and the web, and we've got a couple objectives for this lesson. Let's talk about what they are. So, objective number one is I hope that each and every one of you will be able to explain what the internet is. And I hope that each and every one of you will be able to explain what the web is. So we're going to do the same thing from this morning, but you'll do it on your own. And hopefully shore up your answer a little bit. Pretty good answers overall this morning. Let's do some takeaways. What were some things that were new to you that you thought were interesting? Share.
The amount of people it took to go from creating the internet to creating the web
Mm-hmm.
all along the way. No one can say, oh, so and so created the internet. No, it was like a collection of people
Yeah.
that did it.
And at the same time, I find it interesting how few people were involved in that CERN project for the web. But yeah, excellent takeaway. What else?
I didn't include this on our answer, but it was something that I was reading was it broke it down by year and what percentage of the global population is now using the internet and how it's exponentially growing year after year. I know that's not really to do with these questions, but I just thought that was a fascinating tidbit about the internet.
When I was in high school, like 2000 or so, I was in Montana, and there was some gal who was there, and I said, "Hey, so y'all have the internet out here?" And that was like kind of a real question because half the country wasn't on the internet. that was a thing that you could not be. Cool. Other things you found interesting or shocking or new in your research this morning?
All right, I'll say one more thing. I find it very interesting that it started out as just packet switching,
Yeah.
essentially. I mean, that's kind of crazy.
Right?
Yeah.
It's all like duct tape and string, man. Like there's like it's really conceptually not that complex a system. And so it's pretty amazing that it works as well as it does. All right, let's talk about this first objective, what the internet is. So a network of computers kind of looks like this. You've got a bunch of nodes on the network. And the point of it is that they can all talk to each other because they are networked together. So your home network kind of works like this. This might be like your laptop and your TV and your cell phone and somebody else's cell phone, person who's coming over and visiting. And this might be I'll put another one over here. Then you might have like your router. Your router is a node on your network that everything else can connect to also. All right, so on that network, everything has an address. That's how they can all talk to each other. So your laptop might be 192.168.0.150. That's what mine is. This one might be 192.168.0.4. This one might be 192.168.0.2. And your router is probably 192.168.0.1. So if one of these devices on the network wants to send a message of any kind to another member of this network, they send it to their IP address. So these are IP addresses on a network. That format of like some numbers, dot some numbers, dot some numbers, dot some numbers. It's really just like another way to say like a number. They're in these groups. So you have 0 to 255 dot 0 to 255 all the way down. Just 4 sets of them. That is an IPv4 IP address. Technically speaking, it can be anything in between here. So that could be 4.251.1.0. Totally valid IP address. In practice, home networks generally start with 192.168.0. They could be anything, though. Out on the public internet, which we'll talk about in a second, like these could be anything. In practice, huge ranges of these numbers are like allocated to specific companies. But they all serve the same purpose. It's like a phone number. Like it's actually exactly like a phone number. If your cell phone wants to send a file to your laptop, looks up the phone number, it sends it over to them. Cool. That's networking. It's not internetworking, but that's networking. Ask me some questions about it.
Can the IP format and IP address have other characters opposed from numbers? Let's say potentially a letter.
Not an IPv4 address. You may have remembered like a mild panic about 5 to 10 years ago about how we were running out of IP addresses. Because like you can have a lot. $255 times 255 times 255 times 255. That's a hell of a lot of IP addresses. But this is also the public internet is kind of limited by the same thing. And so as you might imagine, worldwide, we did actually start running out of these. So there's another scheme totally backwards compatible with the one I just described called IPv6. And those addresses look like this. That's what an IPv6 address looks like. And so those have letters in them, but it's not just random letters. They're hexadecimal. So the letters only go A to F.
And these are for the public domain, right?
Like there's zero reason. Like a few billion IP addresses will serve any local network. So like, yeah, I think they only get used on the public internet.
Okay, cool.
Other questions?
Why does it stop at 255?
That's an excellent question. Anybody know why it stops at 255? It's kind of an arbitrary number.
Because of the hexadecimal system?
Ooh, not because of hexadecimal specifically, but you're in the ballpark. Keep going. It's another kind of counting system.
Does that have to do with binary?
Yeah, there we go. So we'll talk more about binary another day, but the way that it works is like a normal number could be 0 or 1 or 2 or 3. We've got 10 different options for like any particular place. And so if you have 9 and you want one more, well, then you write that. That becomes a 0. We get another like place. Like it's like, I don't know if you've thought about that. That's like a system. It's kind of arbitrary. It could be anything. And then this goes up to 9. And then when that hits 9, then that flips over again. So it just keeps getting bigger, but in each position we can go up to 9. So you could also write the numbers with just 0 and 1. So that's 0, that's 1. If I want another number, it works the exact same way. So in binary, that's 2. And then if I want 3, that's 3. And then, all right, if I want 4, then it's that. If I want 5, it's that. If I want 6, like, and so on. So it might seem like that's super limiting, and it is. What's the value of binary? Why that instead of trinary or quadrinary? Why is it useful to just have binary?
It's like a light switch. It's off or on.
Yep. Which means that we can use what to represent numbers? If it's just off or on, well, I mean, cool story, but like, what does that get us? We can represent a number with just off or on.
0 or 1?
Yep. So 0, 1, off or on, who cares? Why
Access or no access.
Yep, all of those things. But why that? Why not?
Because it represents, so the amount of times the switch goes on or off will directly intercourse with the number you're trying to represent to the machine.
Machine? Why might the machine value this just being on or off? Not three
because
numbers or 4 numbers or whatever.
Conductors themselves that you find within your machine only operate within those on or off switches.
Yeah. A little bit easier to do this with electricity if it's just on or off. So the way that it works is if there is a voltage present, that's a 1. If there's not voltage present, that's a 0. That's a 0. That's a 0. That's a 1. And so the presence or absence of electricity can be used to represent numbers. If we go beep, 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 there you go. Okay, cool. That means whatever. So, like, the implication there, we got timing that we kind of have to worry about that. We group these together. And so a really common grouping of those is called a byte. It's just 8 ons or offs. So 0, 0, 0, 0, 0, 0. So that is a byte. If they were all on, one, two, three, four, five, six, seven, 8, it would look like this. And so if they're all zeros, that's obviously 0. But if they're all ones, all right, well, that place is worth 1 in decimal. This one is worth 2 in decimal. This one is worth 4 in decimal. This one's worth 8 in decimal. So what I mean by worth is if that is on, we can call that a 1. If that one's on, we can call it a 2. So if it was just these, that would be 3, because you just add them together. If it was just these 3 here, we might call that 7. If it was just these 4, well, 7 plus 8, that'd be 15. So you can just keep going. All right. Any guesses what it is if you add them all together?
255.
Oh, not 255. Good guess. Real close.
256.
256. But
Because we got a 0.
But if I also need to keep track of 0, that's 255. There are 256 different possible values.
In fact, not having that accounted for is a glitch in the first generation Pokemon games where an 100% possible thing will miss 1 out of 256 times.
There you go. So that's why it is 255. That is a long answer to a short question. Other questions about IP addresses, networks.
Going into subnetting or anything, are we?
Nope.
Awesome. I hated that.
This is about like as in depth as we really get with networking in this program. But let's get this a little bit more concrete. So if I go into, hey, take a look at that IP address up there. So that's my router. And if I log into it, I go, all right, these are all of the things in my house right now that are on my network. That is their address on my network in this column. This is their MAC address. It has nothing to do with Apple Macintosh computers. This is like a fingerprint. Every digital device in the world is supposed to have a unique MAC address. So let me see if there's one I can log into. Ooh, I might be able to log into the Mac Mini. So that's at 192.168.0.120. If I wanted to like log into that, I might be able to, I'm not sure if this will work. 192.168.0.120. Nope, wouldn't let me do it. Even inside the network, they have to like authorize you for that. But this is exactly that diagram that I had. That's the real thing. So this one that I'm at right now, this router, that's where I'm at in my browser. This is the gateway to the rest of the internet. Because you also have one of these networks. And your office has one too. And my mom and dad have one. And there's one in South Africa right now. And there's one over here. So all of these like individual networks. All over the world. And these routers connect them together. So they all have their own 192.168.0 whatever. But these routers, these have 2 addresses. These have an internal network address, and then they have a public one that goes out to the internet. This one might be, well, let's see what mine is. Okay, so that one is me on the public internet right now. So my router is 192.168.0.1 on my home network, and 98.43.48.256 on the public internet. So each of these has a router that also has a public URL, and those are networked together. And any of them can send each other messages. So it is a network of networks. Ask me questions about that. That's a heady one.
This might be kind of an unconventional question, but going back to some of my older video game days, so when you'd play on, say, a public network like Xbox Live, your public IP would be showing, and if people got mad at you, they could flood your router, overload it with packets and stuff. But that's just because they found your public IP address?
Yep. Yeah, so you guys have my public IP address right now. You could, you could give it a shot. You could do that same thing. If you send this so many requests that it can't process them, that could effectively take down my internet.
Yeah, Kyle, are you inviting us to DDoS you right now?
No, we're not going to do that.
Now, like, something that's changed since then is, like, I do have some, like, not a ton. I have some detection stuff on my router, and my ISP probably could catch that also. Because we don't talk directly. We actually talk through these big nodes called ISPs. That's Comcast and CenturyLink and whoever else. So they can detect some of that kind of stuff, and they might shut it down. I also have my router looking for some of that kind of stuff. And then, like, you can just ban those requests. But, like, yes, that is a valid attack vector.
The other question I have kind of in regards to that, so does your public IP address give off your location?
Not really.
Okay.
You can usually, like, figure out, like, what city someone is in based on their IP address, but, like, not much more than that. And, like, if you've ever used a VPN or something before, what they're doing is, this is your home network. You run all of your requests through somebody else that has a totally different public IP address, and they do all the requests and just forward back the responses to you. And so whoever you are making that request to doesn't actually know who your home network was because you ran it through someone else. And so that person who is getting the requests, they only know the person who is making the request's public IP address. They don't know that that person was a proxy, basically.
That's annoying for location services.
Yeah. Yes. Yes, it is.
So this public network, that's the IP address that is literally the one that's sending and retrieving messages to other networks and servers.
Yep. These other, like, things on the internet, they know that the request came from this network, the 98.43.48.26. They do not know that my laptop was the one that was making them. The only visibility the internet has into my requests is my router. More questions about this. So when I say what's my IP address, Google can figure that out. It can figure out my router. It does not know that 192.168.0.150 on that network made the request. In fact, if I look over at, if I refresh this, the reason it knows that is oh shoot. Nope, it's a lower level than that. I was going to say because I sent it to them in a header, but it's actually even more low than that. But like when somebody requests something, that request has to come from somewhere. That's how they know. More questions about the internet? Cool. So I'm going to throw out an inbox question. I want you to look up your address on the internet. What is your public IP address? All right, questions up on inbox. Let me know.
Just to clarify, you wanted a definition or a specific public IP address?
I want you to look up your IP address and put it in there.
Okay.
Mine came back as one of those
That's fine.
IPv6 addresses. Is that okay? Okay.
That's fine. That's actually kind of fascinating, seeing which of you have IPv6 ones and which of you have IPv4 ones. That's pretty cool.
So, kind of off topic while everyone's doing it, what does that tell us? I mean, if I have an IPv6 and Bryce has an IPv4, right?
Yeah.
So what's the difference between Bryce's and mine's public network identification?
None. Like, they all actually use IPv6, like, under the hood. But IPv4 addresses are backwards compatible. They just add zeros to it to get the IPv6 version. But, like, no difference. I guess it just means that, like, whoever issued you your IP address, like, it's kind of like having a 720 area code in Denver versus a 303 area code. Like, it's the same kind of thing.
Okay.
Sean, who's your internet provider?
I am using Comcast. Yeah, Xfinity Comcast.
Okay. I was wondering if it came down to the ISP, but
Yeah.
Now, Kyle, on what is my IP address.com, it says it gave me my IPv6 address, but it says no IPv4 detected.
Yeah, that's totally fine.
Okay.
So IPv4 addresses are backwards compatible with v6 addresses, but not the other way around.
Okay.
So if you have a v6 address, you would not necessarily have a v4 address. Cool. All right. Looks like y'all were able to locate that. So let's go back to the original objective. Actually, let's think if I want to do one more thing with this. Yeah. So I keep mentioning, like, we send messages on this. Those messages could be anything. They can be strings. They can be complex data structures. They can be formatted in all kinds of different ways. And most of the time, like, it's a real, there's no, like, programming language or something. It's literally just beeps and boops. So most of the time, you're sending like just strings of characters that if they're formatted a particular way, the thing that gets your message goes, oh, you want to send an email. Oh, you want to request a web page. Oh, you want to send me a file. But it's just characters that are kind of formatted a particular way. And the one that we're going to be spending the next 15 weeks talking about is called HTTP. We'll dig into that when we start talking about the web. But for now, let's go back to our objectives.
So Kyle,
Yeah.
aside from DDoSing somebody,
Yeah.
why is it important to know your public IP address?
It's not important to know your public IP address. Really, I just wanted you to see yourself on this chart. And what that chart looks like full size, check this out. Map of the internet. That's not like a cool nebula or something. That is the internet. Let me see if I can find one with a call-out box on it.
It does look like neural mapping. It's
Right?
kinda cool.
Map of internet. Let's see, that's one. Let's show that one that can show the little local. There it is. That's the one I want. Come on, Wicked Media Commons. There we go. All right, so all those little spindlies on this look like that. That's your public. You have an address on that. That's how we can move information, communication, all that stuff anywhere in the world. Totally wild. Other questions? All right, so new question going out in inbox. Explain what the internet is. All right, it's live.
Real quick question too, Kyle, while everyone's filling out the question. Because you talked briefly about MAC addresses being the fingerprint of a machine, and you said that most machines should have a MAC address. If you weren't to have a MAC address associated with whatever electronic device you were using, would you not be able to access certain places on the internet because it doesn't register a fingerprint, or does it not matter?
It's probably that your router wouldn't issue you a local IP address, so you couldn't get onto a local network.
Okay.
Because they're like, I'm not going to let... It's like letting somebody on an airplane without an ID. Like, you could probably configure a router that would do that, but yeah, I don't know how it would know how to get you back the web page that you asked for without that.
I see.
Now, like, something that's more likely is that something would have a MAC address that was cloned off of something else. And you might have like two things on the same network that have the same MAC address, which would probably just crash your network. But yeah, that's supposed to be like burned into the chip. And there's a company that manages those MAC addresses. Issue MAC addresses. There we go. Just Entropy. Yeah, here you go. Things that put network cards and stuff are issued these MAC addresses, and then they get like burned into the chip. Great question.
Seeing that map kind of blew me away.
Right? Me too. All right.
Like, how, dude, that's so amazing that we were able to achieve that.
I know.
So Kyle, the public IP address would be your network IP address, and then your private IP address would be your computer, your local computer. Is that correct? Okay.
So like, I can log on to my laptop from my phone when they're both on my home network. That's the address that they see with each other. Nothing outside of my house sees these numbers, though. You probably have the same numbers in your house. The router is what kind of abstracts all that away.
Would your public IP address change machine to machine if they're on the same internal network?
No, they should all be the same. So if I did that, what's my IP address on my cell phone or my laptop or my TV or whatever, should be the same answer for all of them.
Oh, that's so weird. I got two different ones on two
That is
machines
weird.
next to me.
Also, your public IP address isn't like a fixed thing. Your IP or your ISP issues you that, but they can change it, and they often do. Like, as people, like when you unplug your router, you might get the same public IP address back, but like honestly, probably not. Because like your ISP probably gave that IP address to somebody else, and then they're going to issue you another one. You can pay extra to have a static IP address, but that's not necessary for most people.
Could it be the VPN giving him giving him two different IP addresses?
Mm-hmm.
Well, and now I've got three because I tried on two computers in my phone.
Wild.
What the heck I did.
But yeah, like VPNs absolutely do that because all of your stuff goes through them, and so that's who's making the real request to Google or whatever. They're just forwarding you back the results. Cool. Your answers are great. The only thing I would caution you about is that the World Wide Web does not need to come into any discussion about the internet. That is a platform on top of the internet. You can describe how the internet works without talking about the web. One other like cool internet thing that I want to highlight is that it's not actually like this sort of like star thing that I did. They go in loops. So if this is your home network, your home network is on a loop that's like your neighborhood or your street or something like that. So each of these, that's like every house on your street. And then those are all serviced by your ISP. But like, you could have a noisy neighbor that is like screwing up the internet traffic for your street because the ISP, like we're talking about like the physical wiring of this at this point. You guys do share some of the infrastructure together. And then so like I'm in Denver, so this is maybe all of Denver. And then those are connected by things called backbones. And so that's Denver, and that's Colorado Springs, and that's New Mexico. And then those backbones all connect with each other. It's the same idea like the whole way down. And the map of backbones is kind of interesting too. U.S. Internet Backbone Map. Oops, that was 92. What is it now? There we go. Okay, that's what the backbones kind of look like. They crisscross all over the country. They're these big loops, and they're all owned by different people. So like this one that kind of loops through here. If you're really ready to have your mind blown, the only reason that this loop can talk to this loop is that the people that own those loops are like, oh yeah, you can, we'll take your traffic, as long as you take ours. And that's not like the law or something. That's like a more like a gentleman's agreement. It's like a pinky swear. And there was actually an incident in the last 15 years or so where one of the backbone owners was like, meh, having a spat with somebody else they thought was being too noisy on the network. And so they stopped doing it and the internet fell apart. Like I said, it is duct tape, tin cans, strings. Like, it's really not a fancy system. So it is extremely remarkable that it works as well as it does. Cool. Let's talk about the web. So my favorite thing that I saw from this morning was the group that had the internet is like the Strip in Las Vegas. And the web is the individual casinos and restaurants and stuff. That's pretty good. So
we were proud of that.
Nice. So the web is a platform built on top of this. So I mentioned that like these messages that you send between the computers, they're just characters. They could be anything. Well, one such format that somebody came up with for these messages was HTTP. And so HTTP, what's HTTP stand for? Shout it out.
Hypertext Transfer Protocol.
Yeah. Hypertext Transfer Protocol. A protocol, like, it's not like a fancy computer science-y thing. It's just an agreement on how the message is formatted. You format your messages this way. We'll call that HTTP. And so HTTP requests look like this. So if I go down to, all right, this is my request. There you go. It's just characters. Like if you just wrote those in a text editor and sent them, like it also works. But if you format your request like this and then send it to a computer on a network, and they understand HTTP too, they can interpret this request and do something with it. So that's this idea behind HTTP. It could be, we could have been sending email, we could have been sending video, we could have been sending files, we're sending hypertext requests, requesting that somebody transfer hypertext to us. Where have we seen that word hypertext before?
HTML.
It's the H and the T in HTML. That would be our hypertext markup language. Quick aside, anybody know why it's called hypertext? What is the hypertexty part of it?
It always makes me think of like a hyperdrive from a sci-fi show.
Yeah.
Right? So it's like it's the text that takes you to that location.
Yeah, exactly. Linked documents, and that idea actually like predates the web quite a bit. But the idea that you have a document and then it has a link, and you can click on the link and go to a different document—that's hypertext. And so you can request a document that has been marked up. Hey, like Markdown, that thing we've been doing. If a document is marked up with hypertext, you can request that a computer on that network transfer you that hypertext document. And if you format your message using the protocol, they understand it and they send you the contents of that document. Ta-da! And then, well, what are you going to do with a document with just a bunch of angle brackets and tags and what have you? Well, you'll have a web browser that knows how to read these hypertext documents and render them. At the core, like, this is the web. If this was all we had, we would still have a pretty viable web. One other thing that, like, I don't think is required for the web, but sure damn does make it nice, is the idea of URLs. So a URL, be prepared to have your mind blown again. It's just a nickname for an IP address. Because it's like really hard to memorize IP addresses. So like Google's is, where is it? All right, there's Google's. Yeah, I also love to go to 142.250.72.4, or I could just go to google.com, but check it out. If I copy that IP address and just put it into my browser, check where it takes me. Just nicknames. That's kind of the core part of the web. There's tons of other like aspects of this we'll talk about in a sec, but like this is the real meat and potatoes of it. What questions do you have?
So the HTTP, this is not so much a tool that you utilize, but is it better to describe it as the process of what's happening when one server is communicating with another, or one network is communicating with another network?
So when I open my browser and say, go to google.com, my browser, some of you like picked up on DNS this morning. Love that. My browser asks a service called DNS, or domain name service, which is a phone book for IP addresses. It goes google.com. Well, let me look up the IP address for that. And then it does. Phone book for IP addresses. You go google.com, looks up the IP address, and then your browser formats an HTTP request for you to that IP address. That IP address gets the request, goes, oh, I have a document that's marked up with HTML. Would you like it? And they send it back. And your browser gets that HTTP, the HTTP response that has the contents of this document and renders it. And that's the web in a nutshell. So yeah, you don't format the HTTP request, your browser does it for you.
This might be a dumb question too, but if it's how is it able to complete all those tasks so quickly? Because that's a lot of steps to go through in a fraction of a second to
Oh
pull up a
man,
website.
you don't know the half of it. So there's like the secure version of HTTP, HTTPS, which is what makes it so that like you can feel comfortable putting your credit card on the internet and stuff. The amount of stuff that happens before you ever see the page is nuts. Like you and the site you're connecting to negotiate an entire encryption scheme and like agree on it before any actual communication happens. The request goes out, the file is retrieved, from the halfway around the world, comes back to your and shows up in under a second. Like you're not misunderstanding this. It is actually that fast.
And that's only possible because all we're using is ones and zeros, like we said before, right? It's so, whereas it's doing all these things, incredible amount of things, it's so fast because it's just switches going on and off.
Yep. And like, so you might have, just as a consumer, you might have been familiar with fiber internet. So with those little beeps and boops, like we just ran out of capacity on copper wires. There's only so quickly it can detect the voltage on and off and stuff. And so fiber is like, it's like a tube of glass. And so it's divining all those ones and zeros out of different colored streams of light. And so like, if it's this kind of green, well, that means this collection of, a million like ones and zeros. And so that's how they've like increased all the throughput on that. Crazy.
Is that why fiber optics is so much faster?
Yes.
Than okay, because I just switched from Spectrum. That's what we have in Florida to Frontier, and I noticed that the biggest change was my upload speed. My upload speed was like 20 megabytes per second with Spectrum, and then with Frontier, it increased to 947, which is like fast.
And some of that is your ISP. Like ISPs throttle you on that stuff, where like they'll give you better down speed than up speed, because most people don't need up speed as quickly, and it's all just capacity to them. So that's one of the ways they can make the service more efficient. And also, copper wire isn't doing those kinds of speeds. There's just a lot more capacity in fiber.
Gotcha. Thank you.
All right, so let's draw this out. Your browser which is on your computer. Let's do the whole thing. Asks DNS. They don't use HTTP for this. There's a special protocol. But again, protocol, just a particular format. Says, hey, DNS, what's the IP address for google.com? They give it back to you. Also, one of the ways they speed that up is the next time you ask for the IP address for google.com, your computer has it cached. And then when you blow out your cache, your router also has it cached. And then your ISP has it cached. So there are some like smoke and mirrors tricks to help it speed up. And then this is, say, someone else's computer. And let's say they have a file that I want called index.html. And once I get that IP address, I go, gimme. And that computer responds with the contents of that file. And then when my browser gets that, it goes, hey, I know how to speak this. And then renders it on your screen. That's the web. Questions?
Okay, I have one more quick question. Sorry to keep
Good.
dominating the questions here, guys. Earlier you said that the internet is basically just duct tape together,
You
right?
are correct.
I guess my overall question is, if it's so flimsy in that sense that it's got to be kind of duct tape constantly,
Yeah.
how are they able to keep it up pretty much all the time?
They don't. You just don't notice when it goes down. Like, and there's a lot of redundancy in it. And so, like, there are tons of failover systems for when some big chunk of this goes down. But a thing you'll start hearing in tech circles is like US East 1 is down. So like these somebody else's computers, like most of those computers are owned by Amazon, Google, and to a way smaller extent Microsoft. They have these just huge banks. And even when you're using another service, like I was showing you guys Heroku last week. Heroku is just on top of Amazon Web Services. So a lot of those are controlled by 3 companies. And they're in different physical locations because it does affect how quickly all this happens, like the physical location. If you're connecting to a server in Malaysia, like it is going to be slow. If you're connecting to a server that's down the street from you, it's going to be fast. And so those companies try to like stash these huge banks of computers all over the world. And when one of them goes down, like US East 1 is a fairly large one for Amazon, like, yeah, a quarter of the internet breaks. And as a consumer, your experience of that is like, internet's being a little funny today. Because you'll still see some of it. 100% of the internet isn't hosted on AWS US East 1. And there's like another one in Ohio that like you're probably getting some assets from too. And so like half the web page loads. And then you go to your friends, they go, oh yeah, the internet's being funny for me too. That's the duct tape falling apart.
So essentially what you're saying is that let's say one node goes down, US East 1 goes down, the other nodes closest to that would take traffic from where it went down?
You can configure them to do that. Not everybody does. And obviously Amazon is trying to like patch that stuff as best it can. But yeah, and also like the internet is just kind of useless for 3 hours. Another one, this one happened just a couple of years ago. The left pad incident. This one was big enough that it kind of made the non-tech news just because it screwed things up so much. But left pad is a very small program. Here, we can look at the source code for it. Yeah. Let's see, where is it? There we go. There you go. That is 100% of the code of this thing. And what it does is it adds spaces in front of something. So if you wanted the number 1, but it needed to take up 5 spaces no matter what, it would be space 1. But if it was 1,000, it would be space 1,000. It's just guaranteeing that it always takes up like a certain like number of characters. So that's the algorithm for it. It is not crazy complicated or anything. What is the input? How much are we padding it? What am I padding it with? So one person made this and open sourced it, so anybody else could use it too. And then they got really mad that they felt like their work wasn't appreciated. They felt like NPM had introduced all kinds of draconian measures, and they didn't want to be a part of this anymore. They said, fuck this, table flipped, took their Legos and went home. Like, there were so many things that depended on this, and all of them broke instantly. And so let's see if it says how many different things broke. Yeah, it's just some 28-year-old deleted 11 lines of code, and I mean it was tens of thousands of packages ultimately depended on that. And so people's apps and sites just, yeah, he got rid of 273 other packages he did, which also didn't help. But yeah, he was allowed to do that. It was his code. He was allowed to take it off of NPM, broke the entire internet. There we go. Downloaded.
If a company had the program already coded into theirs, how could it have broken theirs?
Because the way that this works, as you will see in this program, like, let's say there was a bug in LeftPad, or a security issue or something. You don't want that to be on you to fix that. You want the people who work on LeftPad to fix that. So you just say, my code depends on LeftPad version 1. And rather than like copying all that code into your project and moving on, it actually fetches that dynamically every time you build the app. Modern apps are built hundreds of times a day. And so one time when it was doing those the build broke because it couldn't get the new version because it didn't exist anymore. But like, here's a practical example. The LMS, so like that's a React app. I didn't like copy paste React into this. What I did was I said, I want, this thing depends on, where is it? Oh, it's the wrong one. So this is a React app. I just said, I want React at least version 17. And every single time I do npm install, it goes out to the internet and tries to see if there's a more recent version than that I can use. And it downloads it and it puts it in this folder. There we go. So here's all the code for React. But every time I install or rebuild the app, it goes out and sees if it can download a newer version. That's what broke the internet.
For something so simple, wouldn't it have been a whole lot better for a company to just copy those 11 lines of code and use it in their code? Or?
But here's the thing. The companies weren't using LeftPad. It was things like React. It was dependencies of dependencies of dependencies. It was something like pretty format. I didn't install pretty format. Some other package in here needed pretty format. And why didn't they just copy all of them? Like, look through this. This isn't even that complicated an app. This is something I built in a month. Look at all of this like outside code that I used. Like, I wasn't going to write all of that. And if I did have to write all of that, like, that would have taken me years and years and years to do all of this. There's just no way. And even if I said, all right, well, I'm just going to keep this exactly like it is, they find new security vulnerabilities in this stuff daily. That's why you always want the latest version. It would take a staff of thousands to like manually update all the security stuff in this every day.
Isn't that like what at least during the pre-work stuff referencing in CSS, that somebody else has already built it. You can just reference that in your file.
Exactly. Now, at your company, you have, like, NPM actually changed quite a bit after the left pad thing. That particular thing can't happen anymore, but it did. And not every company got hit so hard by that. So what you guys do is use a proxy. You don't actually use the real NPM. You use like a fake version of it that has like hand-approved stuff. Now, I don't actually think that that's any more secure than using the real one, for like the reason I just mentioned. Like, okay, now it's on your IT department to like know when to update something, and I trust the overmind of the internet to do that better than any IT department can. But yeah, that's how that can happen. Duct tape, man. Other questions about the web?
Is it? I'm sorry to also be dominating this question section. When we're talking about how you build these things and everything is kind of like cherry picking at a buffet line, if you will. So
Yeah.
Kyle, if you wanted to build an app, all you really do is, or like, well, I got an idea and here's the code for that idea. And I'm just going to go along the buffet line. And I like how MySpace used that. And I like how Farmer's app used that. And
Yep.
You just go along and pick and choose and throw that into your source code.
Correct.
And you don't need to worry about intellectual properties or anything like that. You're just like, and here's my app.
You need to worry about licensing. So now the good news is that the internet has grown up in a way that makes that very favorable to you. But the reason, so React is a Facebook product. And the reason, oh, maybe not. I'll bet it's React.js. Hang on. Yeah, there we go. Where's regular React? Shoot. React, GitHub. Oh, it's under the Facebook. GitHub.org. So the reason that I can use this to make my LMS without paying Facebook anything is this license. So this tells you what you're allowed to do. And sometimes it means that you're allowed to read the code, but you're not allowed to copy it or modify it. Sometimes it means, so yeah, here's the permissions, kind of in plain language. Sometimes it means you can make a derivative work, but you have to, any changes you make to it, you have to send back to the person who made it originally. There's the thing called copylefting, which is if you use this work in a derivative work, it also is open source. So I couldn't use, so if React had a copyleft license, if I make a React app, it is also by default MIT licensed. That's not actually the case with React, but there's all these different licenses. Like the one I just described was called GPL. There's a dozen of these different licenses, and that determines what you're allowed to steal from someone, basically. MIT is a really permissive one. That's like a super basic default. You can make you can sell, you can make it private, you can change it, you can do whatever you want with it, is MIT. But yeah, that process you described of, I want to make my own app. And so I'm going to take some code from over here. I'm going to take the workflow of this thing. I'm going to steal from this and steal from this. Yeah, that's how app development works. Like that's not like a dirty secret or anything. That is the process of making software, and it's still really hard.
I won't lie. I actually took a piece of your page for my own.
Good.
When we were building our
pages. I was hoping somebody would.
I did too. I used the camera. The picture wobbled.
Yep.
And so that's just a normal thing. That's like crowdsourcing to the max, and that's the whole web.
That is the philosophy of the web. Yes.
That's crazy.
Or like you've probably run across W3 schools because their searchability is so damn good. It's gotten better, but it's still a pretty shitty site. The way better one is MDN. This is managed by Mozilla, but this is just written by regular people. So this thing on the color scheme thing, where's the link? There we go. I can fork this repo and go, no, you got this totally wrong. And then make the edit there and then just send it back to them. That is how these documents all got made. It's just people go, no, it should be this. You're totally missing this thing. And then they added it. It's just like Wikipedia. Same thing with React. Check this out. What was that?
I was just going to say, during the pre-work, Sean and I lived basically on MDN.
Nice. So like React, as I said, it's like Facebook owns it, but these 15,000 commits, not all of these 1,500 people that have worked on this are Facebook employees. In fact, I'd be surprised if more than like 200 of them are. If you want a feature in a piece of open source software, you add it and then you contribute it back, and then you are using the work of a lot of other people doing that. It's a really cool system, and it is ungoverned and it is anarchic, and it works. You've been using the internet probably for most of or all of your life, and that is how it has worked that whole time.
So literally everything that you use that accesses the internet, whether it's Kyle's app or it's Bryce going in to do a Call of Duty competitive play, it's always standing on the shoulder of giants, of someone else. Correct. That might have been a genius never recognized for what they produced and put out there.
Oh man, there's a graphic. It's an old one, but I've seen it going around a lot lately. The internet is a house of cards. Let's see if I can find the graphic. Internet stack thanklessly maintaining. There we go. Like, this is 100% the truth. That's what left pad was.
So for some company like Facebook, they have this React software that they're throwing money at.
Yeah.
A ton. But it's open source. So
correct.
Where's the payback for them for something like that?
What a great question. So there are a lot of reasons that companies, especially big companies, will do open source. Some benefit that they get out of it, first is that it's free. Like, you're already doing the work anyway, so it doesn't cost you anything to open source it. Second is that you also get free labor out of it. Like I mentioned, most of those React contributors are probably not Facebook employees. That means they're working for free on a thing that Facebook gets to use in their internal projects. So like that benefits them. Also, like any kind of security issue, rather than relying on Facebook's very competent engineers to handle that, now you have them plus the entire Uber mind of the internet. it is a way for them to vet people. You want to get a job at Facebook, being a contributor to their open source repositories certainly like helps you jump the line a little bit. It is a way to demonstrate goodwill to the software community. Like Facebook's a pretty hated company in software worlds for like privacy issues, all kinds of other things. So their work on open source does a lot to quell that. And I think that actually Microsoft has probably done the absolute best at that in the last 5 years or so. They bought GitHub and then they made it better. They took their like closed source, super shut off ecosystem, but very good integrated develop environment called Visual Studio, and then made VS Code for free. And it was so good that most of the software community like immediately switched over to VS Code. And they open sourced it. And so it's like a lot of that stuff makes people shift away from going like, Microsoft, 90s, Windows, shitty. Nah, nah. Apple, on the other hand, is hip and cool. Like, really, the last 5 years, Microsoft has done way cooler things than Apple has in the open source community. It makes people think better of them, which makes them want to work there. So, like, that makes somebody apply to Microsoft, but maybe not Google or Facebook or Apple. So all of those are reasons why they do that. Other questions about the web?
I'm sorry if you answered this already, but when you gave the example earlier of like US East 1 goes down,
Yeah.
whose job is it to fix it?
Amazon. So those are... All right, so if this is the country, there's Texas, and this is my gorgeous map of the United States. So if you're Amazon, you want servers all over the country for redundancy, and so that if I'm on the East Coast, my stuff is served by a computer that's on the East Coast. So they never tell you the exact location because, as you might imagine, this is straight up like a terrorist target kind of thing. So nobody knows exactly where any of these things are. That's why they give them names like US East 1. But let's say that server is here and that server is here, and there's one in Ohio and there's two in Oregon. And I feel like there's one like in Phoenix or New Mexico maybe. So they have these data centers here. And yeah, they're huge. Like, check this out. AWS data center. Like, that's what they look like. And all of them are just row after row of things like this. And just impossibly big. So they have those sprinkled around the country, and they give them names like US East 1, US East 2, Oregon 1, Oregon 2. But yeah, those are nicknames for those data centers. Google has their own ones, and so Google might be here and here and here. Like, they take a shit ton of electricity to run these, and so where they are is like, what kinds of tax breaks can we get? How cheap is electricity here? What kinds of natural cooling sources do we, or can we be close to water? Like that sort of stuff. All right, moment of truth. I would like to hear your explanation of what the web is. So questions going out in inbox right now. In just a second. As it wakes that server back up. There we go. All right, questions out. All right, these are a little rougher than the internet one was. Some of them are pretty good though. Okay, so a couple clarifications I want to make. So when we're using the web is like specifically exchanging information, documents, these kinds of things. It's not just navigating the internet. It's the types of tasks that you're doing also. So like email by itself, not a web technology. Email predated the web by a lot. You can just send messages through the internet without domains, without browsers, without HTTP, DNS, any of that kind of stuff. Not needed for email. Now, you might use like webmail, like Gmail, where you are accessing a website that is showing a stored list of emails. That's using the web to work with email. But email is an example of like a technology that exists kind of separate from the web. It is not just websites. So like we're doing websites right now. It's also web apps, and it's also APIs and some other technologies. Websites are just one kind of thing that we do on the web. Cool. All right, before we break, any more questions about the internet and the web? Going once, going twice. Sold. Have a good lunch.
Thank you.
Thanks, bye.